tell us a little bit about SillyBot.
Yeah. Oh, well, yeah. Hello. Thank you, Neda, and thank you for all the organizers for having me tonight. I'm super excited to present my project. One thing I did in my software engineering career is to go from like doing web services that serviced like 10,000 query per second down to soldering my own boards and 3D printing the casing. But today I'm going to talk about a small project that I started last month. So it's going to be a very content-dense presentation, but there's going to be theory for the first 10 minutes, but after that it's just demo. So if you snooze, just wake up in 10 minutes. I'm going to go pretty fast, so stay awake. The project itself, basically what happened is that my younger child was like, hey, Dad, maybe I'd like to program. I was like, oh. And I was like, well, he's always on Discord and making memes. I was like, well, maybe I should make a bot that makes memes. So basically, that's how the project started. A week later, he comes to me and it's like, oh, forget it, Dad. So I was like, oh, fuck. And sorry for the swearing. And I was like, well, how can I salvage the project? And I decided to present it to you guys, so I hope you enjoy it. So here's the project. It's SillyBot, the meme lord in training. The requirements I had is that it had to be fun, easy to use. My kid was using Windows, but I'm mostly using Linux and Mac, so it had to work on all platforms. I didn't want to buy hardware. I'm really cheap, so I didn't want it to cost anything, actually. And I wanted to really be quick to develop, so I decided to develop it in the best language that exists in the world, which is Go. I considered a lot of backends, and I realized that most of these backends are actually just wrapper for Llama servers. I was like, cut the middleman and just use the real thing. I decided to use Hugging Face diffusers because it's actually a good library, and I didn't find anything equivalent in C++. So before I get to the demo, I want to talk about two things. And the first thing is LLM models, because the idea there is I wanted the bot to be creative in creating memes. So I wanted to use LLM to do the creativity. As Greg mentioned earlier, there's been a lot of models that were released in the past 3 months. All of these were released in the past 3 months. And what is really interesting is, first, the context window is becoming really large, and the license is getting better. So a lot of models were released under the MIT and Apache license, and the size is getting in the range that is actually runnable, that you can run locally. On the theory side, still, if you look at the models, the B there is for billions. And for example, if I take a model that is 12B, it's 12 billions. That's a lot. And this is actually the number of weights in the model, and each weight is a number. And how do computers represent numbers? It represents it with floating points. And if you use Google Sheet, or if you're sorry and use Excel, you use 64 bits numbers. But it's too large, and models are generally trained with 32 bits floating points. That's 4 bits per number, which is 48 gig of RAM. That's too much. But thankfully, we now have all the models that were released actually this year were released in this format, which is bfloat16. And who can tell me what the B stands for? Billion. No. Nobody knows what the B stands for? Cyrus knows, but yeah. No. Oh, OK. Ah. Interesting. Oh, you were alone. So actually, the B stands for Google Brain. I'm sorry, but that's true. And basically what happened is that when Google started creating AI in 2014, they created their first hardware-accelerated chip in 2015, and it was doing integer calculation. And the first thing they realized is that it sucked. So they were like, but Float 16 was not really good, so they decided, well, we're going to make our hardware, and the current existing format doesn't work. We're going to invent our first new number format, and that's when in 2017, the TPU v2 started supporting bfloat16. that was the first use of this format to represent numbers. And if you go all the way to the present time, the TPU v5P handles pretty good performance relative to an NVIDIA H100 NVL that was actually released actually last year. But the biggest difference is that with the TPU, you can connect all the chips together in 3D torus, which means that the actual addressable RAM is 570 terabytes of RAM without involving the CPU. Where in the H100, it's actually only in pairs with NVL, which is actually only 2 chips. I'm not a Google employee anymore, so I'm not here to sell anything. Actually, the problem with these is that you cannot actually buy these. You can only rent these, and I think that it's a really big error on Google's part, but that's another story. The other thing is that actually buying one of these cards is kind of the price of a car, which is kind of a problem. But the problem here is that I want to run on my laptop, and this is still too big. What can I do? Well, there's a technique that was developed last year that is called block-based quantization, and this is magical. What it does is that basically, if you've been running LLMs a bit and have been following the recent models, you've heard like, oh, Q4, 1, or things like that. And it's like, and what it is, something. And basically what it says is that it's the base number of bits per weight. And in this case, it's 4 bits per weight. We go from 16 to 4, which is a dramatic reduction of 4x. To make up for it, each of the blocks are actually balanced through an alpha that extend the range, and then a bias that increase the baseline. And then after that, each of the blocks are themselves multiplied. But the problem with the 2 first form is that it was not good enough. And that's when the K form was invented last year. And the fun thing is that I was looking like, what does the M mean? It means medium. I was like, come on. And the fun thing is that really just someone like whipped up a lot of conditions and was like, oh, that's good enough. But the really fun thing there is that, for example, in medium generally, they add 1 bit to specific tensors. So for LLMs, the important tensors are the attention one. And these, when they are degraded too much, they actually get much worse and impact the quality of the model much more than the other tensors. So it's really important to not do the quantization at the same level for every tensors. And that's why the K form is so powerful. And then you see like, oh, they should have designed like really great code to decide how to do the quantization of each tensor. Actually, it's a work of art, which is 300 lines of conditions, like poorly formatted. It's ugly. I found a bug 3 days ago to refactor that. I got positive feedback. So maybe it's going to be rewritten. But the idea there is that basically they look, is it an attention? And then like, is it a 4? We'll do 6 and whatever. And it kind of worked good enough. But it doesn't matter. And that's the nice thing. Because the nice thing is that how the structure is actually stored on disk is well done. And this is absolutely great. So for example, when you have 5-bit numbers, 5-bit is so small. But to make it really efficient on a GPU or a CPU, they store the 4 bits packed together, and then the high bit, the 5th bit, packed together, so that the access in the cache just fits the cache line super nicely. And that's what it makes it so powerful. The fun thing is that the researchers don't really know about it. And so I actually tweeted one of the researchers at Hugging Face this morning. He was like, I filed an issue about that. We should actually investigate that. It's like, yes, it's been a year, but anyway. But the fun thing is that, I'm sorry, it's an old graph, and that's the last part of the theory. But the x-axis there is the size of the model, up to 100 gig. And the y-axis is called the perplexity, which is how confident the model it is about predicting the next word. So the higher it is, the worse it is. And the fun thing is that the original model is twice as the 8-bit model, which is the next dot, so the square versus the first dot. The funny thing is that, oh, that's fine. The 8-bit is almost the same perplexity as the 16-bit. The degradation is measurable, but it's not that bad. And it is what is fascinating is that you can go down to 3 to 1 bit and still actually get something that works. It's not going to be as good, but it still works, and that is what is really impressive. Okay, enough talking, and I'm going to do demo. So I like trouble, so I decided to not use 1 laptop, but 3 laptops. So my preferred laptop is this Chromebook. I paid it last year $1,150, tax included, and it runs LLMs. I'm using a really cheap LLM just because the demo I wanted to be fast, but it's OK. I'm going to do a demo of image generation on Windows and then a MacBook Pro. That is way too expensive. Let's see that. So the way it works is basically I start a bot. It started. And then I go in Discord and then say, hi. And then we can see on the left-hand side that it got the message. It sent that to the LLM that is running locally. And then hopefully it's going to reply really quickly. And it's actually really slow. OK. There's a bug that I added 3 days ago where it actually gets the answer but doesn't send it to Discord, which is like kind of the point. But anyway, so it's just going to come up in a few seconds. And basically, there's a joke there that is sent back, and then it takes it from the LLM and sends it back to Discord so that then you can start to have a conversation. That is like the most simple chatbot that you can create. Like, that's the idea. But now let's make images, because the goal there is to make images. So what I'm going to do is to change that. And don't forget to start the server. So I'll try to not forget this time. And I'm going to go to Windows. So that's my Windows laptop. And I'm going to start the image generation server. I'd like for you to look at the memory usage on the GPU. So this one has a dedicated GPU of 8 GB of RAM. Don't buy it. It's actually not good. And when I load the model, it takes about 4.7 GB of RAM to load the model. I'm using the SegMind SDXL distilled model, which is 1 billion parameters. And I use Aurora to accelerate it. So I only need to do like 8 steps to generate images. Anyway, so then I enable the image generation, and then I restart the server. So as you can see, quitting and starting the server is really fast. That's not Python. And then we can actually ask the bot to generate images. So hope you have ideas. So let's say Mimoto. So who would like to generate a meme about something? So it would be like a collection of words that like the LLM could interpret to generate something sarcastic. So
about electric unicycle.
Sorry?
Let's make a joke about electric unicycle.
The what? I did. Sorry.
Electric unicycle.
Electric inside?
Unicycle.
Oh, unicycle. Oh, OK, this one. OK. Unicycle. This one? OK. Do you want to add something about it, or falling, or it's going to be more fun if you add.
Unicycle weight.
Wait.
Weight, how heavy?
Oh, wait. OK. So at that point, what it's going to do is that it takes the text, it generates labels for it, it takes the labels and the original text, it sends that to generate the image prompt, and then it sends the image prompt to my this one. And this machine now takes the image, runs the 8 steps to generate the image, and send it back to the other machine. What you'll see there is that it's actually using almost 12 GB of RAM. So in this case, I would recommend to get a video card with 12 GB of RAM to get good performance. The performance is still good enough, but like it would be much better if everything fit in the GPU memory. So if we get back, then we're starting to get our images there. And that's weird, but yeah, that's OK. Oh, there's something about weight. And yeah, we could probably try something else. And there you go. What the heck? OK, that was maybe not the best one, but OK. You get the idea. But the funny thing about that is that, so there's two things. So there's the meme automatic, and then there's the meme manual, where you can actually say, like, here's the labels I want to use, here's the description of the image, and then like actually really go much more deeper and precise. And then you can also use the image for the same thing, where you say like image auto or image manual. It won't have labels, and then it would just generate the image. So for the sake of time, I will continue, but yeah, you get the idea. That's it, and then I will go to the MacBook Pro now. That's my MacBook Pro. So right now, my MacBook Pro is running the prod version of Silibot, and it's running a different model. So on my Chromebook, I've been using a Qwen 2, really, really small model, just for like the speed. On this one, I've been running a larger model, Mistral Nemo, that was released 12 days ago. And so with this one, I started adding a bit more functionality. So if I go there and talk with Silibot, the nice thing about it is that you can do things that are much more complicated. It's a much more evolved LLM. And basically what I can do is, what time is it? And normally you ask a model, what time is it? It will say, eh. So it will just like invent a number. But here, that's not what is happening. So the LLM gets the content of the user, but it's also provided a list of tools that it can use. And basically what it does is that it's going to try to think about how to use the tools and eventually get to the point where, oh, come on. Oh. Okay. Oh, okay, that's why. Okay, sorry. Yes. Thank you. So there, hopefully, it will figure out that what is the user intent, will look at the tools that it has available, and then figure out from that how to answer the user. But it won't actually answer the user. What it will say is, actually, no, I don't want to reply to the user. What I want to do is to tell me what time is it. So what happened is that it replied with get today current clock time, and the Go code returned the time, gave that back to the LLM, and the LLM will take the string, which is Tuesday, today on July 30th, with the time including second. And normally when it replies, oh, that's interesting. It's probably the first time it ever did that. Generally, it only says the hour and minutes, but nothing else. So it's kind of interesting. That's the joy with LLMs. You never know what they are going to generate. But also the other thing I can do with it is like, oh, calculate, and like I just type like random numbers. And it's going to be like the kind of similar thought process. In this case, the model is kind of slow on the MacBook Pro. So I was using Instruct v0.3, which is almost half of the size, and it's much more performant. But I wanted to demo Nemo instead because it was released 12 days ago. But the general idea is the same. It's going to realize that it needs to call the tool. It's going to send the tool back to the user and to the bot, sorry. The bot will do the function call, send that back to the LLM, and then after that, the LLM will reply with what it decides. So yeah, it just happened. So it called the function calculate. The operations, I have the 4 basic operations. The numbers as strings. It returns the actual results, sends that back to the LLM, and the LLM replies. It's kind of dry. It just replies with the number, nothing else. Could have been nicer, but it's OK. So that's the demo. Hope you enjoyed it. Function calling is kind of a hot topic these days, so that's why I wanted to demo it. Hope you like that. The thing about that is that the MacBook Pro is way too expensive. You're much better to buy a Chromebook and just have a huge gaming workstation at home, and like you're still going to have 1,000 to spare and actually like enjoy it. So I actually don't recommend either of these computers. Some observations before I leave. Actually, hardware support for Apple improved a lot this year, but before that it was kind of hit or miss. But on the other hand, the CPUs are actually getting much better. Like the Chromebook has absolutely no hardware acceleration and still drives it. The RAM bandwidth is the limiting factor. And that's the biggest advantage of the MacBook, is that the RAM is really high speed. The large context actually has been a problem because all the models that were released were like 128K, and that really kills the performance. So if you want to do stuff locally, actually prefer models with really, really small context window. It will help a lot. On the other hand, if you can scale down the weights as much as you can, you will just reduce the amount of RAM bandwidth needed, so it's going to help. And if you can, don't use Python. It's okay like to use Python. I'm not against that. But I wanted to figure out how much I could extract juice from a computer. I feel that the server-side mode is slightly eroding. The models that are being released are becoming more and more competent, and so many companies are actually fight these days to release competent models. I feel that server-side will still stay useful when you need a trillion weights model, but for most usage, we're getting into an age where the LLMs are going to run locally. I was kind of surprised there's almost no activity in text-to-image. So for example, the model I used to generate the image are from November, which is like so old. My prediction is that we're going to start seeing super block quantization-aware trained model, and that there's going to be research in weight compression. I feel that we're kind of in the early compression, image compression of like the 80s and 90s, and that it's going to be a big deal. The ratios of like the number of weights versus the precision of the weights is something that will evolve in the coming months. And also for the hardware side, the RAM bandwidth versus the number of operations that the chip can do. Try it out. I'll put it later. Before I leave, I'm a member of the Capital Angel Network, and they are organizing a really nice meetup. It's capped at 250 people. So if you're a founder interested into getting investor readiness or just networking with other founders, I really encourage you to come. I'm going to be there, and there's an after party too. So that's it, and there's other subjects of talks that I could give after if you found this one interesting. And other than that, I'm going to take questions. Thank you. No. Yes. But actually, the way to fix that is, hear me out. So the way it works if you want to not use custom stuff is you describe all the tools in Markdown, you send that in as the system prompt, and then you force the model to reply with JSON. And then it's forced to only use one of the functions you give, which one will be send message to user, or the other ones being like actually one of the functions. And that's what GBNF is about. Right now, GBNF is, there's only a compiler in Python, and the example was another work of art. And so I sent a PR last week to completely rewrite it, and it's now much more readable, but still, if someone is interested, it's something I'd like to do in Go. So if you like the language, it could be interesting. But yes, so right now it's using the hard coding that Mistral is doing. But it's not limited to that. There.
A question about the language. So, what is the advantage of using Go or C++ instead of Python? Yeah, and do you have any measurements or how much more performant is that?
It's always about trade-offs. Like, for example, I was talking with other people earlier today, and like, if your trade-off is like getting to market as fast as possible and like grabbing as much as the market, go with Python. Like, it's fine. Like, it's the best thing. In my case, it was an exercise of fitting on a laptop. Like, I exactly wanted to reduce the memory usage, the CPU time, things like that. Sorry. Go is still a large model from standards that like it's a GC language. It takes more RAM, but in this case, like it's negligible. It didn't matter. Why I chose it? I just type faster in Go, and I can write unit tests and enjoy it, which is really rare. And Cyrus, I was talking to Cyrus and was like, because actually one of the hardest, like, you know, the hardest part of this project, you know, it was actually splitting the lines. Like, when you ask it to write a lot of code, like, and where do you split? Like, and it's actually complicated because, like, LLMs generate Markdown, but, like, really crappy Markdown. And, like, I had to figure out, like, but this code will only accept 2,000 characters. So I actually had to process the Markdown and, like, figure out, like, if it decides to, like, spew a block of 3,000 characters, what do I do with it? And so I decided to write a function to like figure out how to split, and I wrote unit tests for that with full coverage. And Cyrus looked at me and was like, "What the heck, guy?" But if I had did that in C++ or in Python, I wouldn't have written the unit test, and then the code would suck. But it's okay.
Thanks for your presentation. I had a question about the function calling. So you mentioned that the functions that it was calling here were like given to the LLM.
Yes.
I guess we're capable of this, but have you tested it writing the functions themselves, like interpreting what function would answer the question, writing that function, and executing that function in like a sandbox? Is that something that's on the table? Do you know much about that?
You have to have trust in the LLM. In this case, like literally the function is that. And it tries to understand the numbers because sometimes it just doesn't provide the numbers. And then after that, like I describe the function. And you have to be eloquent, use the exact right words. So for example, like in this case, it's arithmetic. And like figure out like actually how to describe it in the most precise way and hope for the best.
Any more questions?
Yeah.
I have a question. So as a founder who's always trying to look out for like a deal or something free to use, is running large language models and serving that in a commercial context, is that against terms and services or GitHub?
Can you repeat that? I'm sorry.
So your second bullet there, run LLMs for free.
Yeah.
Actions,
Yeah.
Is that against terms and
I do that.
services?
Yeah, so basically what I do is that I'm cheap. And so basically when I run actions to run tests, because I wrote tests, I wanted to actually test the LLMs. So basically when it runs, anyway. So literally, even on Windows, like it's kind of funny because it takes 2 minutes to download Go, and I don't know why. But running the test actually takes like 52 seconds. And what it does is literally downloading a model and then like running it. And that actually works on the free quota if you figure out how to run things properly. And like on the Linux machine, the whole thing takes like 43 seconds to run. And that includes all of the overhead. And, but you have to understand the performance implications of your choice. And once you understand all the performance implication of what you're doing, then you can figure out how to optimize it in a way that for the unit test, I don't need like a super smart LLM. Like I use like the most, like literally I use literally like the worst LLM I could use, the smallest one that still passed the unit test with high confidence, and that's it. So I really recommend everyone to use that because then you have something that is much more reproducible and you can run it locally. And in this case, it downloads about 500 megs of data. And the funny thing is that the slowest one is the macOS. So that's how I discovered that the macOS runner on GitHub really have shitty network compared to the other ones. So that was kind of funny. Yeah. That's it. Okay, so thank you all, and I hope you enjoyed this talk.
Thanks for that presentation.